Dear colleagues, we're glad to introduce you our team project homework for data management analysis. We have created an operation database that supports the streaming service website. Each user can create an account on this website by purchasing a package and share the account with family members or friends by creating a profile for every member. The allowed number of profiles depends on the package, which of course has different price. So in the streaming service you can find a great number of world movies and TV series. Every of those motion pictures has a short description and information about data release, country, its actors and directors, and of course age restriction that is necessary in our country. All movies or TV shows are divided into different genres. As one can belong to several genres, as you can choose a picture from the list of your favorite genre. And I should also add that there are different languages of audio and subtitles in the streaming service for more comfortable watching.
The viewing of each video is recorded when the profile started watching it, whether it was watched. So the next time you log in, there's an option to continue viewing. As each TV shows and movie has its own statistics, which is formed by viewing each profile of corresponding series or movies, so that statistic can be used for potential users of our database. For example, by combining the age of profiles into age groups, it is possible to form the rating of top films and TV series for each age category. For data modeling, we use tools which were taught on our DMA lessons, ERD+. I have to say it's not far the best tool for data modeling. Nevertheless, we created about 20 entities for our database. Entities, account packages, and profiles were already somehow described a couple minutes ago. Next, we created a motion picture entity which are connected with TV shows and movie by relationship of type. We did this because one movie is corresponding one-to-one to a video, but TV shows consist of several seasons, and seasons entity consists of several episodes, which are recorded on a video. Looking ahead, we inserted 252 episodes for one example of motion picture entity Bones. After we created an entity people, the same person may be both an actor and director for a motion picture, for example, Clint Eastwood. So we needed entities act in and direct in the model. It is shown like many-to-many relationship between the motion picture and people in ER diagram. The same thing we done for subtitles to video, audio to video, and resolution to video relationship. The complete list of all entities attributes is shown on ER diagram of our report.
For transaction tables, we created the views entity. It fixed the watching of each video when the profile started watching it, when stopped, and view status that is finished for viewing more than 95% of a video and stop for other cases. In the beginning, it had to be cool both function and trigger of our database as automatic generating the attribute view status, but unfortunately we're running out of time. By the way, about running of time, how it happened. Using Excel, we filled the database with test data. We took the list of TV shows and movies from Kaggle Corporation's public web platform using opening datasets. These tables have corresponding 1,990 and 9,968 rows, and that was a big mistake. We lost time to create data for all TV shows set entities. Finally, we copied description only for Bond's TV show. Other entities we filled by ourselves. After we created a database named DEMA2021 and first letters of our second names through the Beaver tool.
My name is Valuev Bogdan, and now I want to present to you our work related to queries. Okay, let's start. We know that many are willing to pay a little more than usual, so first query shows number of accounts that have a premium package. Who likes to watch movies and shows the most? The answer to this question will make a second query, which shows the account that is the leader by number of viewed videos among those who are in top 5 by their duration of usage of the service. A lot of people remember actors from movies or TV shows, so third query shows people that direct pictures or acting pictures and the respected pictures also. Fourth query writes an average age of people that are over 18 and are the top 10 that were registered earlier than the others. For long series fans, we created fifth query, which shows names of seasons of TV shows that have more than 200 episodes, grouping by release date of the season in ascending order. Sixth queries shows information about profiles of the account that was firstly activated on the platform. It's about statistics. Seventh query will provide you with an ordered list of episodes for each TV show grouped by number of views of the episode, among others within the same show. And the last eighth query writes type of length of the season based on the number of episodes that it consists of. That's all what I wanted to say. Thanks for your attention. And now I want to give the floor to my colleague Yulia.
Thank Bogdan. As for functions, we came up with three following ones. They are all pretty interesting, but let me begin with the most interesting one. This function is called show category. This function returns name of the category of a particular TV show. So firstly, it's finding information about TV show based on picture of the TV show. Then we'll find the category of a picture by checking its category ID in categories table. Finally, we receive category name of a provided TV show. As for other functions, one null file is the number of episodes of the TV show that is deleted but saves the ID of the deleted shows. For instance, if the TV show has 300 episodes but we decide to delete the TV show from database, then it will recreate but with the same ID that was before and number of episodes set to 0. We called it public show delete. The last function, which is called alt_update1, returns whether the profile is full-aged based on provided date of birth or not. The principle is the following. The loop inside the function goes through all profiles in the database, takes their date of birth, calculate whether the owner of profiles is over 18 or not, and writes true or false to indicate the status of full age. It's extremely useful as we need to know age of our users to set appropriate restrictions. Thank you very much for your attention. Our team finished work. I hope you enjoyed. Goodbye.